Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss some quiz questions related to regression. Okay, so these particular quiz questions will be based on all the topics related to regression, whatever I have covered, like simple linear regression, multiple regression, polynomial regression, maybe some other kind of regression I have also discussed, like exponential regression and so on. Okay, multiple non-linear regression also I have discussed, the visualization, the programming part, the theoretical intuition, whatever. Based on that, let us try to solve these quiz questions, and all these quiz questions are going to help you in the placement process related to machine learning or data science interview. Okay, so here comes the first question. Multiple linear regression is appropriate for option A, predicting the sales amount based on month, option B, predicting whether a drug is effective for a patient based on her characteristics, option C, predicting tomorrow's rainfall amount based on the wind speed and temperature. Pause my video, try to think about the correct answer. Here I am explaining. Okay, so no doubt the correct answer is option C, because see, here based on month we have to predict sales amount, single variable linear regression problem, predicting whether a drug is effective for a patient based on her characteristics. So multiple input feature might be present for this case, but this is classification problem, not a regression. Predicting whether a drug is effective means either yes, drug is effective, that time the outcome will be 1, or else outcome will be 0, right? So this is one classification problem. So option 2 cannot be the correct answer. So option C, and you can understand easily here, rainfall is dependent on wind speed and temperature, two input variables, okay, or independent features, one dependent output feature. So this is nothing but a multiple linear regression use case. Okay, right. Coming to the next question. Which of the following is the meaning of out of sample accuracy in the context of evaluation of models? Okay. Out of sample accuracy is the percentage of correct predictions that the model makes on the data that the model has not been trained on. Okay, and option B is, and the second option is, out of sample accuracy is the accuracy of an overlay trained model which may capture noise and produced a non-generalized model. Okay, now pause my video, try to think about the correct answer. Here I am explaining. No doubt the correct answer is option A. From the name itself you can understand, out of sample accuracy. On our sample training data we create our machine learning model, then we basically test our model based on such data which we have not used for training our machine learning model, right? That is called test data set. So that is nothing but out of sample accuracy. From this particular term itself you can get a feeling about the answer, and the correct answer is no doubt option A. Okay, now coming to the next question, and this is multiple option correct type question. Okay, so it might happen that multiple options are correct. When should we use multiple linear regression? Option A, when we would like to identify the strength of the effect that the independent variables have on a dependent variable. Option B, when there are multiple dependent variables. And option C, when we would like to predict the impact of changes in independent variables on a dependent variable. Pause my video, try to think about the correct answer. Here I am explaining. Okay, so no doubt the second option is wrong, because anyway in multiple linear regression it is not like that we will be having multiple dependent variable. Dependent variable means output. Okay, only single outcome, continuous outcome only we predict using our multiple linear regression, right? Second option is wrong. Now if you recall, what is multiple linear regression equation? Y equal to theta naught plus theta 1 into first variable, maybe that is x1, plus theta 2, okay, multiplied by second variable x2, plus so on dot theta n multiplied by xn if there are n input features are present. Now what I have told you in the intuition part, this theta 1, theta 2 are basically telling how these x1, x2, these features are impacting on our outcome variable. Okay, if the sign is positive for these values, theta naught, theta 1, so on theta n, then those are impacting in a positive way. If the signs are negative, that means those are impacting in a negative way. The x1, x2 are impacting in a negative way. Okay, and if theta 1 value or theta 2 value is more, that means they are impacting in a more better way, we can say. Okay, right. So that's the simple idea, right? Now, from this, let us try to get the correct answer. So, when we would like to identify the strength of the effect that the independent variables have on the dependent variable. Yes, this is what multiple linear regression is, because suppose what we do, to test the effect, basically here we keep x2 so on xn as constant, okay, and we change x1 and we try to get the idea that how the change in x1 is affecting in the output, okay, and that is completely dependent on this theta 1 value also, right? This in the intuition part itself I have told you. So basically multiple linear regression gives us one basically mechanism using which we can test the or understand the strength of the effect that independent variables are changed, then what is the effect in the outcome or dependent variable. So option 1 is correct, and let's take option C. When we would like to predict the impact of changes of independent variables on a dependent variable. Yes, this is also correct. Okay, so both option A and option C are correct. Okay, so this is the correct answer, right? Coming to the next one. Which of the following statements are true about polynomial regression? Polynomial regression can use the same mechanism as multiple linear regression to find the parameters. Polynomial regression fits a curved line to your data. Polynomial regression models can fit using least square method. Pause my video, try to think about the correct answer. Here I am explaining. No doubt this answer is correct, okay, because it fits polynomial shape curve on our data. Then next one, see, if you just recall polynomial regression normal equation, again y equal to theta naught plus theta 1, maybe first feature is following linear relationship, plus theta 2 x2 square, okay. Suppose there are two input feature x1 and x2, and this is the polynomial regression equation, okay, which for which theta naught, theta 1 and theta 2 we have to find out. Now this is nothing but multiple linear regression only. Now how this polynomial regression can be converted to multiple linear regression? See, very simple. Here theta naught is normal only, plus theta 1 x1 up to here also linearity term is followed. Now x2 is our input feature, but here x2 square is there. Now x2 square, that input feature x2 will be squaring, and that suppose is y, okay. For each value if we square, that's suppose the value is y, that suppose we are telling as let me give some good name, because y is generally denoting the outcome, okay. So here maybe x3, okay, x3 is x2 square. Now see, this is nothing but what? Multiple linear regression, right? I have told this concept also, that different polynomial form of equation can be converted to linear form of equation, and then we can apply the simple linear regression type concept on that to get the values, right? And there is this theta naught, theta 1, so on. So basically this also correct, the first option. Polynomial regression can use the same mechanism as of multiple linear regression to find the parameters. The next one, polynomial regression models can fit using the least square method. Yes, because ultimately whatever regression you follow, the main aim is minimizing the mean square error. Okay, that is our prediction minus actual, square them, then take the take sum of all of those values, and then take the average of that. Okay, that is divide sum value divided by total number of data points present in our training data. So that mean square error we need to minimize always, and we need to find out that theta naught, theta 1, so on, theta n, for which that mean square error can be minimized. Okay, so that is nothing but least square problem use case. So option C is also correct. Coming to the last question. So here actually all three are correct. Which sentence is not true about nonlinear regression? This is single option correct question. Okay, nonlinear regression is a method to model nonlinear relationship between dependent variables and a set of independent variables. Option B, for a model to be considered as nonlinear, y must be nonlinear function of parameters. Nonlinear regression must have more than one dependent variable. Okay, pause my video, try to think about the correct answer. Here I am explaining. So here this particular problem is very simple. No doubt the correct answer is option C, because I have told you that non-linear regression you are applying, multiple linear regression you are applying, multiple non-linear regression or simple linear regression or simple non-linear regression, whatever you are applying, ultimately there will be only one dependent variable, that is outcome variable will be only one. Independent variable can be many, but dependent variable should be only one. But here what it is written, multiple linear regression must have more than one dependent variable, which is completely wrong. Okay, so not true means this is the correct answer, because it should always have one single dependent variable, right? So I hope you have understood this. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe my channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of my latest videos. Thank you.